January 1945. A bitter wind sweeps across the snowy outskirts of a small village in southern Germany. Smoke curls from twisted metal scattered across the frozen ground. The remnants of a massive aircraft lie crumpled against the jagged landscape, its engines torn free, fuselage scarred by fire and impact. The morning light glints off the shattered canopy, revealing glimpses of a pressurized cabin that seems impossibly futuristic. A small group of German scientists and Luftwaffe engineers approaches cautiously, boots crunching in frost-hardened soil. Their eyes widen as they take in the scale. A bomber larger than anything they's most advanced engineers. This is no ordinary crash. It is a revelation, a glimpse of a machine that could strike halfway around the world. A harbinger of power the German mind had never anticipated. By late 1944, the war in Europe had reached a stage of industrial and technological extremes. The Allied forces, having liberated France and pushed the German army toward its borders, were demonstrating capabilities that German strategists struggled to match. Central to this imbalance was air power. The U.S. Army Air Forces had, by this point, established strategic bombing campaigns that could devastate entire cities and disrupt industrial centers hundreds of miles behind front lines. Among the most significant instruments of this campaign was the Boeing B-29 Superfortress, a bomber that represented the pinnacle of Allied aviation technology. The B-29 program had begun in 1940, but it was not until 1944 that it entered operational status over the Pacific. Its design incorporated unprecedented features, a pressurized fuselage, long-range capability of over 3,000 miles with a full bomb load, and defensive armament controlled by analog computing systems design bureaus. The Germans had some knowledge of the B-29 size, pressurization, and defensive automation were often dismissed as exaggerations. 45. The contrast was undeniable. The Allies were fielding long-range, high-altitude bombers capable of sustained operations across oceans, supported by a logistics and manufacturing base that Germany could not hope to replicate. German scientists and officers understood that technological brilliance alone could not close this gap. Resources, industry, and supply chains dictated the ultimate balance of power. When a B-29 finally fell within reach of German eyes, the engineers who approached its wreck were confronting this reality firsthand. The machine before them was not just an aircraft, but a statement of industrial supremacy and operational reach that the Reich had never anticipated. The frozen landscape, the twisted fuselage, and the intact engines would soon provide the first undeniable proof. What had been rumors, sketches, and theoretical reports became tangible, measured, and terrifying. Every rivet, panel, and control surface held evidence of engineering precision, automation, and scale that German minds had yet to fully grasp. It was in this moment, standing over the wreck, that the German scientists first began to reconcile with the truth. The war had moved beyond what any single nation's pressurized cabin allowed crews to operate at altitudes above 30,000 feet, reducing vulnerability to conventional flak and fighters. Its remote-controlled gun turrets, guided by analog computing devices, created defensive arcs that were nearly impossible for interceptors to penetrate without significant risk. Germany, until wrecks and forced landings, offered rare, tangible insight. The war in Europe had also reshaped priorities. Resources that might have gone into experimental long-range bombers or strategic reconnaissance were redirected to defensive systems, jet fighters, anti-aircraft guns, and radar development. Every ton of aluminum, every liter of fuel, every hour of engineering effort was in demand at the front. In this constrained environment, the arrival of a single B-29 wreck represented both a windfall and a bitter reminder of limitations. When German scientists reached the crash site, the frozen fuselage, intact engines, and pressurized cabin revealed realities that no report or rumor could fully convey. They could measure the diameter of the Wright R-3350 engines, examine the bomb bay capable of carrying up to 2,500-pound bombs, and inspect the analog fire control systems that manage remote gun turrets. Each discovery underscored the gap between Allied industrial capability and what Germany could achieve under war conditions. This revelation had immediate implications. Engineers documented every detail, often in sketches and notes, recognizing that while the Reich might learn from this aircraft, replicating its design in the remaining months of the war was impossible. The B-29 embodied a combination of engineering, resources, and manufacturing capacity that Germany could not reproduce. Its very existence symbolized the industrial supremacy of the United States and the scientists' capacity to translate knowledge into global reach. What German scientists saw in the twisted metal, the engines, and the pressurized fuselage would shape their reports, proposals, and the stark realization that the Allied edge was now both technological and industrial, an advantage Germany could observe but not equal. Standing over the B-29 wreck, German scientists and engineers experienced a mixture of astonishment and unease. Their training had prepared them to assess aircraft performance, engines, and aerodynamics, yet nothing in their prior experience had prepared them for the scale and sophistication before their eyes. Faces streaked with soot, frost, and grime reflected disbelief as they traced the bomber the engineers were explorers in a foreign technological landscape, confronting a machine that defied expectation. There was also quiet apprehension. The B-29, we could not stop staring. We had never seen engines this large, controls this sophisticated. It was this human response illustrated the psychological weight of technological inferiority, and foreshadowed the broader realization that Germany all optimized for sustained long-range flight under heavy load. The pressurized cabin was another revelation. German bombers had experimented with high-altitude designs, but none had incorporated fully sealed, climate-controlled compartments. The ability of the B-29 to sustain crew operations at 30,000 feet, beyond the effective ceiling of most Luftwaffe interceptors, fundamentally changed the tactical calculus. Furthermore, the remote-controlled gun turrets, guided by analog computing devices, allowed the bomber to defend itself against interceptors with minimal crew exposure. German scientists could see firsthand the integration of avionics, mechanical systems, and defensive capability reports, sketches, and preliminary analyses were compiled and sent to the Reichsluftfahrtministerium, RLM. High command officers understood that the bomber was not just a technical curiosity, but a symbol of the Allies, whether to focus on interceptors, ground-based anti-aircraft weapons, or emergency countermeasures. While the war was already tilting against Germany, the B-29 represented a tangible embodiment of why industrial and technological inferiority could no longer be mitigated through tactical skill alone. From a tactical perspective, the B-29, a single B-29, could inflict destruction disproportionate to its numbers, a tactical challenge Germany had no ready solution for. The B-29 wreck also carried a profound psychological impact. For the German scientists, it crystallized a truth they had long suspected. The Allies were not only winning battles, but producing machines capable of reshaping the entire conflict. Beyond immediate combat considerations, the B-29 highlighted systemic advantages. German engineers could see that its range, payload, and defensive systems were made possible by an extensive, well-resourced industrial network. Factories, test facilities, and supply chains in the U.S. supported consistent output at a level Germany could never sustain in 1945. Inspecting the wreck, the scientists realized that even if they attempted to replicate the design, the materials, tooling, and manpower required would be unattainable. The machine on the frozen ground symbolized not just engineering, skill, but the integrated power of industrial capacities, declining resources, and infrastructure meant that reactive innovation could never match proactive industrial supremacy. The B-29 wreck, in all its imposing scale and sophistication, became both a study in engineering and a symbol of unbridgeable technological gaps. Engineers and commanders alike recognized that what they saw was more than a machine, even if resources had permitted replication. Attention shifted to the fuselage and pressurized cabin. German engineers traced the sealed compartments, examining oxygen delivery systems, insulation, and structural reinforcements designed to withstand high-altitude flight. The B-29, they were evidence of a capability Germany could neither build nor produce at scale. Rumors of the B-29 it would shape decisions, reports, and the strategic posture of the Luftwaffe for the remainder of the war. Outside, winter wind carried the faint smell of fuel and scorched metal. Officers recorded observations on cameras and in reports to the Reichsluftfahrtministerium. Every measurement, every note, and every sketch would eventually reach decision-makers. Yet the B-29 wreck itself had already delivered its most important message. The war had evolved beyond the limits of German engineering and production. This single machine embodied power, endurance, and technological superiority that could not be ignored. As night fell, the scientists packed their notes and equipment. They left the frozen fuselage behind, its wings casting long shadows in the moonlight. The wreck was both a revelation and a warning. Germany had glimpsed what the Allies could achieve, and it was a scale of power the Reich could never hope to match. The following morning, the analysis resumed under a gray, overcast sky. German scientists returned to the B-29 wreck with renewed focus, this time prioritizing systems integration and operational potential. They disassembled panels where possible, carefully examining wiring harnesses, control linkages, and hydraulic actuators. Each discovery reinforced a grim conclusion. This bomber was a product of coordinated engineering, production, and testing on a scale Germany could no longer achieve. Attention turned to the flight control systems, the B-29's complexity. This was not brute force engineering. It was precision, foresight, and human-machine interface optimized for operational efficiency. The Germans realized that duplicating such refinement would require a manufacturing network, materials, and workforce that simply did not exist in a collapsing Reich. Next came the bomb bay. Massive and modular, it allowed rapid loading and precise deployment. Scientists noted the structural reinforcements, release mechanisms, and hydraulic doors. The potential destructive capacity was staggering. A single B-29 could level factories or entire city blocks with minimal risk to its crew. Tactical implications became clear notebooks filled with diagrams, calculations, and tentative plans for countermeasures. Yet the limitations of reality loomed over every idea. Even if the Luftwaffe could theoretically design a bomber of comparable size, fuel shortages, industrial bottlenecks, and Allied bombing made production impossible. Discussions among officers highlighted frustration. Germany could innovate, but it could not overcome the structural imbalance in resources. This gap, now starkly tangible, transformed awe into strategic concern. By mid-morning, the group focused on the defensive systems. Remote-controlled turrets with analog computers allowed the B-29 to coordinate overlapping fields of fire. Engineers tested the mechanical linkages, simulating targeting sequences. The precision and automation were revolutionary. Even experienced fighter pilots would struggle against concentrated defensive arcs. Every turret, every system component, every engine reinforced a chilling truth. The Allies had not only designed a powerful bomber, but also optimized it for survivability and operational effectiveness. The psychological weight of the discovery was evident. Scientists whispered in disbelief, some visibly shaken, others quietly scribbling calculations that would later inform reports. Senior officers, noting the engineers, they were a warning, a symbol of industrial and technological might far beyond German reach. As the team departed, conversations turned to operational realities. Even if every measurement was applied to design a German counter, the timeline, resources, and strategic position made it futile. The B-29 had revealed not just an engineering marvel, but a systemic truth. The Allies, but never equal. The scene closed with frost-bitten wind sweeping across the wreckage, the bomber resting silently, a testament to both human ingenuity and the shifting tide of war. In the hearts and minds of the engineers, the realization settled. The B-29 was not just a plane. It was a statement-S threat and determining a response. The technical analyses were detailed. Engineers described the R-3350 engines, the pressurized cabin, and the remote-controlled defensive turrets, alongside structural measurements and hydraulic schematics. Yet beyond the technical observations, the reports carried an implicit warning: Germany's long-range, high-altitude, and defensive capabilities. Intercept missions would require concentrated fighter formations and improved radar coordination, both of which strained resources already in decline. Engineers warned that without industrial catch-up, countering the B-29 would rely on opportunistic engagements, mechanical failures, or fortunate circumstances. S-jet and piston engine projects, though innovative, could not match the strategic reach or survivability of the B-29. The stark contrast crystallized the understanding that even brilliant designs could not compensate for structural disadvantages in production and resource availability. In essence, the immediate aftermath of examining the B-29 wreck was a mixture of technical documentation and strategic despair. The Reich possessed brilliant minds, but lacked the industrial foundation to act on the insights gained. The bomber stood as both a marvel and a warning, a symbol of the scale, precision, and foresight that the Allies could mobilize, and a reminder of what Germany had already lost in the contest of modern warfare. As the weeks progressed, the implications of the B-29 examination rippled through German military and scientific circles. Reports were distributed to research bureaus, Luftwaffe leadership, and project offices responsible for jet fighters and high-altitude interceptors. Engineers meticulously referenced measurements of the R-3350 engines, hydraulic systems, and pressurized cabins, seeking insights that might inform future aircraft designs. Yet the sobering reality remained. Germany could document, analyze, and admire, but it could not replicate. Propaganda departments were aware of the potential morale impact. Any public acknowledgement of the B-29's industrial capacity was eroding faster than innovation could compensate. Psychologically, the B-29 wreck left a lasting impression. Scientists who had once prided themselves on technological ingenuity now confronted a machine that symbolized industrial supremacy. The bomber was a physical manifestation of what Germany could not achieve under wartime pressures: integrated systems, high-altitude performance, and long-range operational reach combined with reliable defensive mechanisms. Engineers' lessons. New aircraft projects, though ambitious on paper, were ultimately limited by resource scarcity. Engineers focused on incremental improvements rather than revolutionary breakthroughs. The bomber had illustrated a truth both technical and strategic. Engineering skill alone could not overcome the imbalance of industrial and logistical capacity. The Allied edge was now tangible, measurable, and undeniable. In retrospect, the aftermath of the B-29 wreck was not just the creation of technical reports or strategic recommendations. It was a profound acknowledgement of Germany's final stages. The discovery crystallized an understanding that would shape internal assessments and decision-making in the months leading to surrender. The wreck had transformed from a mere crash site into a symbol S presence forced a reckoning with limitations, priorities, and the realities of industrial warfare. In the larger arc of history, the B-29 symbolized a turning point. It foreshadowed the decisive role of industrial capacity in the final months of the war. The growing impossibility of Germany's influence extends into operational, psychological, and strategic realms.